Well, let's get started. From both Geert and myself, a very warm welcome to this Check Point and Aviatrix Clouding Together seminar. I'll just do a quick introduction. Please, Geert, if you can introduce yourself. I believe it's important that you can give it a little bit of background.
Yeah, sure. So also from my side, warm welcome to everybody to this webinar. So my name is Geert. I'm working for Check Point as a cloud security architect. My area of responsibility is basically the Nordic countries, so Baltics and also including the Benelux. And I'm really excited to do a joint presentation together with Ides, who is part of one of the fastest growing startup companies in the cloud networking today. So yeah, really looking forward, Ides.
Okay. Thank you, Geert. So my name is Ides Vanneuville, responsible for systems engineering. My background is mainly in networking and security. And it's great to do this session together with Check Point, because that's where it all started a couple of years ago for me, being part of the security environment. So what you will see over the next couple of 45 minutes is a combination of course, the Check Point solution, how it fits into the cloud, plus also some hands-on demonstrations. So we'll try to keep it as lively as possible. And of course, if you have some questions, if you have remarks, please feel free to use the chat box, and we'll get back to you as quickly as possible. Okay, I'll leave it up to you.
Yeah, thank you. All right, so let's talk a bit about what's happening at today's organizations these days, and especially when it comes to cloud. You can skip the animations already, yeah, fine. So some customers of mine I see moving to the cloud, typically as an extension of their on-premise data center. I see also other customers that are using clouds for, to drive basically the innovation in a faster way. And they use the cloud's hyperscale platforms to do so in order to deploy scalable infrastructure. And they might use virtual machines like they were using on-premise. Some of them are using containers. And for some capabilities, they might want to use discrete functions. But what I see is that what is happening now is that these customers, they have their data center and applications everywhere, right? So some of the workloads are running on-premise, others are running in the cloud, some are running in multiple clouds, and the data centers are partly on-premise and they are partly in the cloud. Of course, many of them have their data center firewalls with next generation threat prevention capabilities on-premise, but they typically want the same capabilities in the cloud. And most of all, these new requirements, they now need to be implemented at super rapid speeds. They need to change, they need to adapt to this ever-changing environment, and they need to do it at scale. And the only way they can do that is, the only way they can achieve this basically is by adopting security that can be automated. And this goes, when we talk about automation, we talk about either the automated deployment of your security components, all the way to automatically generating, for example, protection profiles or security insights. Because basically there's no way that in these cloud environments, you can manually keep track and keep at pace with your developers or with any changes in the cloud. And this is actually where Aviatrix and CloudGuard come into play. So they're both basically built on the same foundations. I came across Aviatrix, I believe, about a year ago, and I was actually pretty impressed by how they tackle some of the challenges that enterprises have when they want to build their or extend their enterprise networking architectures to the cloud. So in the next couple of minutes, you will learn how Aviatrix takes away some of these challenges. You will learn about the solutions that we built together. We will show you a couple of reference architectures. Also, we will describe a couple of flow scenarios. And we will wrap up with a short demo of the Aviatrix Copilot that Ide will provide. And I will show a couple of elements about the Check Point unified policy that, with integrated cloud objects that will help to make a very seamless, unified multi-cloud security architecture. All right, Ide.
All right. So as of course, Check Point needs little introduction as a company, since it has been around as ever I can imagine even. And I do have already a couple of years down the belt over here. So, but for some of you, Aviatrix might be pretty new on that one. So pretty new, it was founded in 2014, while mainly the clouds were being used as a DevOps type of environment. Basically to have fast provisioning and to start using the agility that the cloud was offering. And it was at that time, in 2016, when the product was released, really focusing on increased efficiency, but also on faster compliance. So it's a very important part that Aviatrix does, because it's born in the cloud for the cloud. In the meantime, of course, the cloud landscape changed dramatically when enterprises are moving their crown jewels of applications, their business applications, their money-generating applications to the cloud. And that's exactly where Aviatrix sits around, because if you use multiple cloud environments, you always have to deal with the very specifics of a single cloud. And that's where we provide that unified layer, which will create a simplicity of the cloud, but also, as Geert already mentioned, taking into account the agility of the cloud. So you also want to automate and bring the enterprise-graded networking, not only to a single cloud and multiple clouds. A very important aspect of these elements is that Aviatrix is a networking company within the multi-cloud networking software environment. But as you know, you cannot really deploy a network without taking into consideration security. The same applies for the other way around. So you cannot really think about security without really having an impact on the network while keeping all things very simple. So some bragging rights over here, just joking, but all these logos that you see over here of the 500 plus customers that we have worldwide, they all came across a specific hurdle when moving into the cloud. Typically, this is related to networking capabilities, which can range from the very simple network address translation type of capabilities with overlapping IPs, but also the secure access into the cloud. And of course, when embracing multiple clouds, then you're facing with the fact that how are you going to interconnect these type of clouds? So in order to keep the speed of adoption, the agility within the cloud, all these logos that you see over here, they turn towards Aviatrix to help them to achieve that agility that they wanted in the cloud. And at the same time, of course, it gives the visibility and taking away some of the shortcomings that you find into the networking layer of each and every cloud provider. A very important part are the different components, and that's where you see the full integration, also with the Check Point over here, and it all starts with the Aviatrix controller. Aviatrix controller is part of a distributed environment, which is then the management plane, and then you see at the bottom of the screen the different data planes. So these are the routers, gateways being deployed as an EC2 instance in AWS, or for example, a virtual machine inside Azure, or any other naming when you go to other type of clouds over here. So the first part is the controller, which is basically deployed from marketplace, your preferred marketplace in your preferred cloud. And what is very important to know is that the Aviatrix platform is not a SaaS solution. So the controller is deployed in your cloud environment, in your preferred VPC or VNet. And out of this controller, the different data plane gateways will be deployed in different VPCs. In a nutshell, what it allows you to do is to build your own network instead of being faced with a toolbox full of different tools in there that you have to stitch together yourself to get to the desired network. A very important element out of the controller, and the name says itself, it's to get into control of your network, is the visibility part, because that's a very closed loop where you enforce certain rules within the network, but then of course you need to have the visibility. Since most of the cloud providers are approaching the network or the network constructs, as we call that one, as a black box principle, the visibility is really low within a single cloud. And even that type of challenge is even aggravated if you need to manage 2, 3, or even 4 clouds, because typically the cloud adoption is not driven by the networking department or, for example, the IT department, but typically is driven by the use of applications which are available in a specific cloud. Once you have deployed your first cloud, your first region, and that's where the automation comes around, then you can typically copy and paste all these different type of sets into all the different type of clouds. So you truly get to a repeatable design. And with our partner Check Point, as you see depicted in the bottom of the screen over here, where you have the firewall symbol, that makes it an integrated network and security environment. So the full API is around to manage different clouds, hence also born in the cloud, but also the API on the networking level towards a checkpoint is available out of the Aviatrix controller. And that means that you have a unified view across any type of cloud, but more importantly, it gives you always a unified experience wherever you deploy your checkpoint solution within that networking environment. Because AWS has a specific way to deploy the checkpoint firewall. Azure has a slightly different way to deploy the checkpoint firewall. GCP, Oracle, Ali Cloud, everybody has their own specific way, which makes it very difficult as a security architect or security ops person to manage all these different type of cloud instances. So what do we do exactly with those core components? We have the controller, we have Copilot, and then out of this one, you have the gateways, which different type of use cases. So the full stack is managed by the Aviatrix controller, and it will also use the cloud API on the different clouds to make sure that you have a complete solution. So for example, if you would be in AWS, you want to attract public traffic, then of course you will need to assign a public IP. So typically that can be done in a manual way, but out of the Aviatrix controller, since we maintain also the API connectivity within the cloud, it will be done in an automated way. So the simplicity increases dramatically over here because you don't really need to be an expert in each and every cloud. So some of the functions that you see over here in the standard architecture, even in a single cloud, it can be as small as a single gateway with an Aviatrix controller, allows you to do, for example, secure access to the cloud. Then, of course, create, for example, microsegmentation, so it can push the data through the checkpoint firewalls so that you have a very granular way on who can talk to who within your cloud environment. So that's the typical, what we call the north-south connectivity from the on-prem environment to the cloud. And then also the east-west communication, which can be in a single region or across regions or even across clouds. So that's a very important point. Also on the access layer, there is a point of importance that I would like to highlight, is that we see typically organizations embracing the cloud. Some organizations, they do already have a on-prem exit strategy, but quite a lot of the larger companies, for example, they will still be embracing the on-prem data center for many years to come. So, and that's also where Aviatrix with its solution brings the cloud inside the on-prem data center. So that means out of the Aviatrix controller that you can also be on the edge of the on-prem environment. So truly stretching out the cloud experience straight into the access layer. The architecture is important for these type of environments because it allows you to design the network as you want to have it. You could be, for example, deploying AWS Transit Gateway in AWS, which is fine, but what are you going to do within an Azure environment? Because there is no AWS Transit Gateway. So for each cloud, without Aviatrix, you will need to define your own architecture and then stitch all these different islands together. And then, of course, day 2 starts, which is typically the operations environment, which is typically the longest day in anybody's career who is in operations. So all these elements, which is active-active, high availability, active mesh between all the different transit routes, it's a very important factor that it's all controlled automatically out of the Aviatrix controller and giving you the visibility by Copilot.
Right, great, Ida. I really like that part, especially where you should demonstrate the unified architecture across clouds, because if you just think about it, I had a couple of discussions lately about the multi-cloud architectures, and customers were asking me, okay, can you show me some best practices of deployment of gateways in Azure? And we discussed the deployment methods that we have, we discussed the routing, we discussed the hub-spoke architecture. And then the customer said, yeah, how can we do this in AWS? And you need to really go back and start from the beginning, but because in AWS it's totally different. You have transit gateway, you might have gateway load balancer, the routing is totally different, let alone if we would talk about GCP, for example. It's again a different way of how you should use their hyperscale platform. So multi-cloud environments and unifying the architecture is really a pain today. And I really think that Aviatrix does a great way in simplifying that. So let's now talk a bit about the joint solutions that we built. And a bit more detail about the reference architectures, I would say. When it comes to extending an enterprise-grade secure network to the cloud, you want to have, or you need to have some next-generation threat prevention capabilities. Without Aviatrix, as I just mentioned, this brings quite some challenges in getting that done. First of all, one of the biggest challenges is the deployment method is all manual. You are responsible of configuring, for example, the VPC route tables. You are responsible for configuring your VNet route tables. You need to take care of all the routing of the traffic from the source to the gateways, make sure that the gateways are configured in a way that return traffic hits the same gateway and that you avoid asymmetric flows. If you would use the AWS Transit Gateway, for example, you actually have to use the IPsec VPN tunnels, right? That connect the Transit Gateway to CloudGuard gateways, for example. Those tunnels have a limit with throughput. I believe it's 2.5 gigabyte per gateway, per VPN tunnel. So that means that you limit the amount of traffic that you send to a single CloudGuard instance, which is an instance that can process much more traffic than the limitation of the VPN tunnel. If you want to use an active-active scenario, you need to implement ECMP. You need to have BGP, which is, of course, fully automated in the deployment of the Check Point CloudGuard gateway. So the whole process of building these VPNs and destroying the VPNs is automated, but it still adds to the complexity of the deployment. If you want to have symmetry, in certain cases, you need to configure, for example, SourceNet, because for SourceNet, it is another mechanism that allows you to make sure that return traffic is being sent to the same instances. But with SourceNet, you lose some of the visibility of the source addresses in your traffic, which is typically for east-west, something you do not want. Okay, when you want to define if specific VPCs, traffic coming from specific VPCs or specific VNets need to be inspected, you need to configure the routing to make sure that traffic sourced from a specific VPC is sent to CloudGuard. With Aviatrix, without Aviatrix, basically, there is no policy-based mechanism to do that. So maybe you are familiar with some software-defined networking technologies on-premise, like Cisco ACI or VMware NSX or anything similar. Then you are used to build policy-based redirections to steer your traffic to specific instances. There is no such thing in cloud, right? You need to do all of that by routing. So Aviatrix is solving quite a lot of these challenges. They deliver policy-based control and management, which allows you to define exactly which VPC, which VNet needs inspection. And it's based on policies. It's not based on routing. So it's really like a modern SDN platform we used to deploy on premise. You have policy-based decisions or traffic steering. Now you can do that as well in the cloud. The deployment of CloudGuard is done in an active-active scenario. So integrating with the transit gateways of Aviatrix is done active-active. Preferably you do that in a centralized location, as you would do in a typical hub-spoke architecture, of course. There is no BGP, there's no ECMP that we need to configure. There is no source net required. Aviatrix takes care of that. It also takes care of the policy-based routing and control. And even more, it maintains the life cycle of CloudGuard gateways. So either you want to deploy CloudGuard gateways typically with the Terraform templates or ARM templates or maybe CloudFormation templates. Here we can do that also from the Aviatrix controller. So the Aviatrix controller takes care of the deployment of the gateways, takes care of the life cycle of the gateways, and you can deployment directly from the controller. And the great thing is, as you just saw in the animation, that this thing is taking care of all traffic types at first. So you can secure ingress traffic coming from the internet. You can secure egress traffic, so everything going from the cloud to the internet. You can secure east-west between your spokes, between your VPCs, to and from your on-premise data center, to and from another cloud. So all traffic flows or traffic types are supported. Also in Azure, also in GCP, the same applies. So you can again secure it in the same way, and also your architecture remains the same. You're not dealing with the routing anymore. You don't have to take care. Okay, it's GCP, so they have a global VPC. There is a shared VPC. They use network tags. They have firewall rules instead of network groups, and the routing table is then totally different than the one in AWS. You don't have to take care of that, right? So the Aviatrix controller takes care of the automation, the orchestration of the networking layer, and the policy-based redirection makes sure that you choose which traffics are inspected by gateways. So you get this unified architecture across these different clouds. So now Eden is going to explain you a bit about packet walk, right, Eden? I think we're going to start with the east-west packet walk to see how that happens.
Yeah, that is correct. And, thanks again, Geert. What you see really, and what I really like about this slide is that you see that unified type of architecture where you have the scalability of the cloud guards within any type of cloud. But the simplicity that you see over here is truly that it's the same way deployed in each and every cloud. So, and that, as Geert pointed out very correctly in that one, every cloud has their own way to define these type of routes, and it makes it extremely difficult to become an expert in 3-4 clouds and still guarantee the highest possible SLA. So let me go to the packet walk to make that a little bit more visible over here. And you actually see 2 VPCs, VNets or VCNs, whatever cloud you are in. And there is a VNet A and a VNet B, and you have a host in there or an EC2 instance, which is 1.10. And it wants to communicate with 2.20, which is in the VNet B. So what we actually do out of the Aviatrix environment is first of all, get all the routes correctly on this one. So we'll do the programming of the individual routers, also sometimes the echoes if it is required to attract the traffic to the spoke gateway, the number 2 that you see over there. Once the traffic starts flowing and all the communication in between the transit gateways and the spokes of Aviatrix is already encrypted. So step number 2 is that there will be a route lookup being done over here. And there is also a check for the microsegmentation that you have applied, for example, on the different networks. And it's with this type of policy-based environment that you will direct the traffic to the checkpoint firewalls. So everything is done within, let's say, number 3 that you see over here, where the traffic is received by the transit gateway, and based on its policies, it knows, of course, where the destination is, which is in VNet B, but then based on the policy itself, the traffic will be forced towards the CloudGuard environment. And of course, we keep track of the different sessions so that, of course, also the traffic, the return traffic is going to the same CloudGuard so that you have the full layer 7 inspection according to your firewall rules. Maybe a note which is important. Of course, Aviatrix can do the deployment of the CloudGuard environment, preferably through automation in Terraform, but you can also do that through the GUI. But the important part of this one is that you still experience the same mature level of managing your firewalls as you did before. So it also means that the process of enforcing security remains the same, whether you're in the cloud, or Cloud B or Cloud C, or one of the on-prem locations where you have already the Check Point firewalls deployed. So a very straightforward design that we put over here. And that of course comes back in the simplicity to manage these type of environments, because each and every step is nicely visible through Copilot, but also we ensure that there is always a symmetric traffic flow between the source and the destination, and of course the return traffic. The other designs, because the one that we described was more for the east-west in the typically hub and spoke type of environments, are the different ingress traffic designs. So in the left-hand side, your left-hand side, you see the external load balancer. Of course, this one has a public IP, which will attract the traffic towards the application, which is depicted in step number 6. So once it hits the external load balancer over here, it will be forwarded to one of the CloudGuards, depending on, let's say, the load balancing rules that you established, and it will be received by one of the transit gateways of Aviatrix. Since the destination is known within the route table itself, it will be forwarded to the appropriate spoke gateway, where it will be delivered to the final stage, which is the web application. Again, it is very important to know that we can return the traffic through the same path, because we have that awareness within the spoke and the transit, and that will also ensure that the traffic will be handled on the return by the same CloudGuard. And of course, we always show a minimum of 2 CloudGuards over here, but you can scale it up to a multitude of those CloudGuards depending on the required capacity. A similar type of design, but slightly different, is that it doesn't always need to be, let's say, in the ingress VPC. There are quite a lot of use cases where, for example, you typically see that the ingress is in a spoke VPC. As you can see on this type of design, it is very similar, where you also have an external load balancer, but the first step that happens is that it will hit the Aviatrix spoke gateway. And once it hits the Aviatrix spoke gateway, the same will apply for all traffic coming outside my domain. It will be subjected to the packet inspection, for example, executed by the CloudGuards. Again, of course, symmetry is guaranteed because we are flow aware, and always the same CloudGuard instance will handle the traffic. So various type of architectures. And of course, it's yours to choose with the advice, of course, of Check Point, which would be the best one. But you see that the network itself is not a bottleneck. On the contrary, it is truly the combination of the Check Point capabilities with Aviatrix that you have that unified, secure networking environment.
Something I can add to that, maybe, Ide.
Yeah.
If you go back to the other design, so the previous, yeah, this one. So for some cases, customers like to handle their ingress traffic like east-west, right? Where they want the ingress to be deployed in a dedicated spoke. That can be for several reasons. Maybe they want to deploy an additional functionality there, like specific web application firewalling capabilities or specific reverse proxying capabilities. This is why this architecture for some customers does make sense. I see also a question either from Eric. He's asking if for the ingress design, the external load balancer is also deployed by the Aviatrix controller. Is that something you can answer?
We can make use of the load balancing function within the different clouds, depending where you are. But it's more on the east-west type of traffic. So for example, on the right-hand slide, if you would be deploying, for example, in Azure on the right-hand part of the slide, then, for example, we will make use of the Azure load balancer, and behind the Azure load balancer will be the CloudGuard instances. That load balancer deployment is fully done by Aviatrix. So depending on the design of the cloud, we will be using different mechanisms to always get the same effect on the uniform controllability of the environment. And I hope that answers the question. So it's a little bit cloud specific. If it is for Azure, yes, the load balancer will be deployed by Aviatrix. Yep.
Cool.
In this design, which is on the left-hand slide, or the left-hand side of the slide, you see the external load balancer, and this will be a dedicated load balancer, which might be part of the same automation stack when you deploy, but it's not part, let's say, of the Aviatrix architecture, because it's hitting directly the CloudGuards before it actually hits the Aviatrix gateway. Okay. Take it away, Geert.
Yes. Let's talk a bit about this specific architecture. In what you can see here is that many cloud deployments at some of my customers, they require a multi-hub approach. Multi-hub meaning that they deploy a dedicated security hub that processes the east-west traffic, so traffic between spokes, between VPCs, between VNets, and a dedicated VPC for ingress and egress traffic. This is a quite typical architecture, and the reason to do that is because it can be a good practice to deploy specific security controls, for example, for different types of traffic. So ingress is typically HTTP traffic. You want to do HTTP inspection, you want to do some web application firewalling, you might need some IPS and auto scaling. East-west is typically much more complex traffic flows, right? Not only HTTP, but also other in-data center traffic flows and traffic types. They require high throughput. They might require different SLAs to the business, sometimes also different maintenance windows. And in cloud, it's always a good idea to separate that, let's say, into smaller services than what we used to do on premise, and trying to secure everything within the same deployment, right? So separating these flows in different VPCs gives you much more flexibility, and also it's helping you to lower the failure domains, right? Whenever something goes wrong with one of the traffic flows, it doesn't impact your other traffic flow and so forth. So the many more flexibility that this architecture gives you. And this is why we created an architecture that reflects this need. So you can use the context-aware traffic steering from the Aviatrix controller, and then it allow it to steer traffic to the appropriate CloudGuard VPC, depending on the source or depending on the traffic type. If you would be using the native options, if you would, for example, again, in AWS, you would be using the transit gateway, you don't have that capability, and you are then limited to the feature set that the CSPs provide you. So if you want to separate specific traffic flows, you need to take the controls of the CSPs, typically routing type of the scenarios, specific routing domains that you configure on the transit gateway or in the UDRs that you configure in your VNets, to make sure that specific traffic is only sent to other VPCs.
Mm-hmm. But what I also liked about this type of environment is that not everything needs to be done at once. So this is fully software, so you don't really are stuck, I would say, to hardware cycles, which is typically a span, depending on the product, between somewhere 4 to 7 years, depending what you're using. But this is all software-based, including the CloudGuards that you have over here. So it's perfectly possible to start with just a collapsed environment where you do east, west, north, south out of a few instances, and then without really to do a complete overhaul of your virtual data center, you can be adding those extra pockets of security whenever you want, because you have that unified transport backbone consisting out of Aviatrix, and that's where you can easily insert those extra topics in there, and really designing the security and the network, also the scalability of it whenever you need it. If you don't need it anymore, just destroy it on that one. If you need to expand into other regions or other clouds, add another one to that one. And that truly gives that flexibility of being in that virtual data center. Let me move to the next slide. Okay.
Yeah, so a couple of words about some deployment types. So either you can still use the native constructs like the AWS Transit Gateway, and leverage the advantages that you get from an Aviatrix controller that takes care of the automation of your network and your native controls of your network. Or you can choose for the common deployment model with the Aviatrix transit environment that makes it a repeatable design, because yeah, transit gateway is not something that exists in GCP or AWS or even OCI. So the transit architecture, though the Aviatrix transit architecture really delivers that unified architecture. But both deployment scenarios still give you the largest advantages. You still have an automated deployment and orchestration, right? It gives you the simplicity of the Aviatrix controller. It is a near seamless deployment because if I discuss this element with my customers, so the hard part has always been the complexity of the deployment itself, right? Once it's deployed, it's fine, but deploying it, no matter what type of automation we build, what type of Terraform templates we script, the hard part has always been enabling our customers. And this has really been severely simplified with the Aviatrix controller. So you have that in both options. You also have the performance advantages, right? The 2.5 gigabyte limit of your IPsec tunnels is gone. You have a very high throughput architecture. We no longer need the source net. So that means, or one of the reasons that we no longer need the source net, because the Aviatrix gateways are doing bidirectional hashing, so they pin the traffic to the firewalls for different sessions. So you don't lose that source address visibility anymore, and you get the visibility of your overall environment. And one of the examples I can give when it comes to visibility, I work closely with one of my former colleagues who's now in the incident response team of Check Point. And that means he takes care of breaches in cloud environments and on-premise environments, and then he helps customers to identify what happened and make sure they get back on track as soon as possible. And the most important thing they need to do whenever they are engaged is to find the source vector of a specific attack. And in order to do so, and especially in cloud, they need to collect a lot of logs, they need to collect a lot of information, and they need to try to find what happened at the very beginning, and then they need to find out what the chain of attack has been. Doing that with the native controls is super hard. He always told me I need so many interfaces, I need so many sources of logs that I need to investigate only in one cloud, let alone if the attack would cross multiple clouds. So getting that visibility of what's going on for either troubleshooting or for just investigating a specific breach is super hard if you don't have like a centralized system that gives you that visibility. And I think this is also something that Aviatrix can really help.
Mm-hmm. Yeah, that's a perfect segue into, let's say, right now it will be 1.5 minutes demonstration, I would say, of Copilot, because ultimately it is that visibility that you require. And it's truly the combination of Aviatrix and Check Point that will give you that full layer 3 up to layer 7 type of visibility, coming maybe, okay, from 2 consoles. But at least it's only 2 consoles that you have to consult, even if you're present in 5 different clouds. So a very quick rundown on the Aviatrix environment, because I do want to respect everybody's time. And also, of course, Geert would like to show a couple of things on the true integration of CloudGuard within the different clouds. So yeah, I will have to leave it to a couple of highlights over here, but Aviatrix Copilot is an integrated part of the Aviatrix solution. And the sole goal of Copilot over here is to help out in day 2 operations. Because on one side, you have control and force control, for example, by CloudGuards in combination with Aviatrix, but how do you try to visualize the data? How do you try to troubleshoot as quickly as you can? So I will have to restrict it just to a couple of highlights over here. And Aviatrix gives you that dynamic real-time feel of how networks are looking like across all the different type of clouds. Let me just truncate a couple of node labels over here. And you see you can actually play with the layout as much as you can over here, really trimming it to your type of needs. You can also cluster it together as you can see over here. This is the same network, but now in a clustered environment. One of the elements over here is the very quick troubleshooting. So over here, you see, for example, a Aviatrix gateway deployed in OCI, the Oracle stack that you see over here, and immediately you can go to the diagnostics of doing direct tests of where that culprit might be. A very important part is that we also show the underlay, typically of the cloud providers, by also giving you all the different latency numbers over here. So automatically, when there is something like the network is slow, because that's always the problem, it's never the application, of course. We all know that as networking and security specialists, it's always the network, and that will give you an insight immediately in how your network is performing, how it is actually behaving. The last topic that I will show over here is the Flow IQ environment, because all the Aviatrix gateways give back the information to Copilot by using NetFlow v5 and v9 over here. But it also allows you to really find that needle in the haystack, and as Geert pointed out with his colleague within the Incident Response Center, truly to find the end-to-end of the flow. When did it happen? Who made it happen? Where did it went to? How did it transit? To which type of firewall was it sent? Where did it came out? And what was the attack vector? And that goes hand in hand with that security on the segmentation. So over here, you have a perfect view, and that's of course enforced by the checkpoint firewalls. If you have those different segments in AWS, but also across clouds, for example, in Azure, each flow between those segments, VNets, VPCs, can be subjected to inspection by the T-packet inspection firewall. So I'll stop over here. So Geert, that you can also share a couple of informations from the CloudGuard environment.
Yeah, I will do that. Let me share my screen as well. Just a second.
And no pressure, Geert. You only have 45 seconds left. Okay.
Is it a hard stop in 45 seconds?
Well, it is. I believe it is for 45 minutes. I don't mind to keep on going, but I leave it to the audience, of course. Yeah, please go ahead here.
Yeah, my demo will not take more than 3 minutes. So basically what I wanted to describe is one of the great things that the Check Point unified policy, and especially unified policy for cloud, allows you to do, which really differentiates us from other solutions. So basically, the management server of the Check Point gateways, which is something you can deploy in your own environment, you can deploy it on premise, you can deploy it in cloud, you can even run it or use it as a service, where basically the management server is hosted at Check Point environment, and you can just use your browser to go to the management portal and use or manage your policies. It has a specific architecture that allows you to build great policies for multiple clouds, and I want to show you exactly a couple of elements that make that interesting. So in this case, for example, you see this one policy package, and in one policy package you can describe your flows for AWS ingress, you can describe flows for AWS egress, you can describe flows for Azure and for GCP, all within the same policy package, and you can just push them to all your gateways. And that means that the gateways, either if they run in Azure or they run in AWS or they run on premise, they will understand if the traffic is coming from an AWS environment and is destination for another environment. So you can really build this multi-cloud security architecture or multi-cloud security policies and just push them to all your gateways. Another advantage is it has threat prevention capabilities for both north-south and east-west, and it's up to you to decide if you want to deploy a single deployment type for all your traffic flows and then just configure IPS, anti-bot, application control, URL filtering, HTTPS inspection, all these type of capabilities on the traffic flows that you require. But it also allows you to do that in a DevSecOps way or automated way. So I did a webinar not so long ago about how we can basically codify our security policy. How can we build a security policy as code? So I used Ansible for the matter, but you can use Terraform if you want to use another orchestration. But Ansible is really great for just configuring environments or configuring systems. In this case, Ansible was used to deploy a fully automated rule set. So your source, destination, your objects, and installing the policies, publishing the policies was all automated. We can also leverage objects from the cloud. So the management server basically uses API calls to the cloud environments, and it uses the cloud objects like a VNet, like a VPC, even tagging to build your policy. So it doesn't make sense anymore in cloud to build your policies based on a static host name and IP address. You need to make sure you leverage more dynamic ways to build this policy. So using tags, for example, using VNet objects makes this much more dynamic. So let me show you how this looks like. I have a management server over here. This management server currently manages a couple of gateways that I have in Azure in this case. I have two policy packages. There is one which is called Northbound. The Northbound policy package has my NAT rules and my policy rules, my access policy rules, and my threat prevention rules for everything when it comes to inbound security. So this policy package just manages all my inbound controls for traffic coming from the internet, including the NAT rules, including the threat prevention rules. I really separate inbound security from my other security because it has, again, as I mentioned, it's a different, I deployed it as separate gateways and I have different requirements. I also have a policy package for southbound. Southbound, in my case, is east-west, outbound to the internet, and maybe also intercloud. So I built, for example, a security policy here, which says, okay, east-west is my security between two spokes. I have a east spoke and I have a west spoke. They're called VNet East and VNet West. I'm not using a static object here. I'm really using a VNet object that gets me the information from the Azure API, and the Azure API will define which IP addresses are attached to that specific object. So for example, I use a VNet object over here, and I have a tagging object over here. So this is a tagging object, which means my machines in Azure with a tag that is called access to east will be applied as a source, and they will be allowed to, for example, go to my VNet East in this case. So I can, in this case, I can add, for example, an additional rule above where I want to use a specific policy, and I want to make sure all VNet East to my VNet West is being secured. So in this case, I will make a VNet West object over here. And instead of doing an accept and drop, I can also make something which is called an inline layer. And this inline layer will allow me to bundle all rules that are applicable of being applicable to this parent rule. So I basically have a parent rule that says east to west and being managed by a dedicated environment. So for example, let me quickly create this inline layer. So it is my east, west inline layer. There you go. And then I apply this east, this access east tagging object to VNet East dynamic object to that rule. And this becomes now an inline layer, which means that this inline layer, which is called east-west, can be managed, for example, by a separate team. So you can have a team that is responsible for my traffic flows between these two VNets. It might be a specific developer team, it might be a specific security operations team, but I can even, for example, create a user or administrator profile for my automation. So I can have, for example, an Ansible user, which is only allowed to manage this inline layer, this east to west inline layer. So that means that Ansible user will not be able to modify my full policy, but it is only allowed to manage this specific policy that takes care of the access of between these two VNets. So these simple things like inline layers, policy packages, but also the use of dynamic objects make this way of building a multi-cloud security policy much more simple, much more granular, and it also allows you to keep, for example, principles like the least privilege. So you make sure that some users only have access to specific parts of your policy and no access to others. So this basically shows, if you want to see more, of course, don't hesitate to reach out. But this is basically a quick glimpse of how a multi-cloud architecture could look like. I think this concludes more or less. Okay, this is my presenter view. Let me quickly change this one so I can show you our last slide with a couple of reference diagrams or reference links, I would say. There you go. So yeah, as I mentioned, don't hesitate to reach out. Here you have our contact details, so both Eden and my email address if you want to have a further discussion and continue the discussion. I added a couple of links. There is a community website from Aviatrix with some great demonstrations how to deploy our environment. There are Terraform templates. There's a GitHub repository for specific traffic flows and specific clouds. I also added the link to the Check Point CloudMates, which is basically part of the Checkmates, a community of people using Check Point solutions. And CloudMates also has some great tutorials how to deploy specific architecture. So also worth visiting if you would like to know more. Yeah, but sure, Ide, if there was something you wanted to add to that.
No, I truly love the cloud integration, and it's great to see that both companies are really working together at elevating the way how new networks are being managed, how they are being secured, by no longer, staring blindly, I would say, on IP addresses or subnets, but truly getting the spirit of the cloud, of working with those attributes, IAM policies, or whatever we can find to identify the dynamics within a cloud. So yeah, really excited about this next step where we can elevate our solutions above, let's say, the layer 3 and the layer 4 environment. That was it, I believe, from our side. We apologize for running a little bit over time, but I hope also from our side that you enjoyed the explanation on how both companies can truly build a secure networking environment across multiple clouds.
Thank you very much. See you guys.
Thank you. Bye-bye.
Bye.